Hey everybody, Aaron Cowan, Sage Dynamics, and this is the C&H Precision V4 Defender Glock MOS plate. If someone were to check the numbers, they would probably find that the Glock MOS is one of, if not the best-selling MOS modular optics platform. It's not because it's the best. That may shock some of you to hear. Some of you are probably nodding along already. I'm a big Glock fan. I like quality. Glock makes a good gun. However, the MOS is not an excellent execution of a modular optics platform. From what we've seen from some other manufacturers and what some aftermarket companies have done, we know that if you're going to make something modular, you may have to compromise in certain areas. However, when it comes to modular systems, I've always kind of scratched my head about the conservative nature of their machining and the fact that it's their gun, they built it, they designed it, they know it inside and out probably better than anybody else could. So why can't they make slight changes to increase the effectiveness of their modular platform? The biggest failing with the MOS is the plate, really. It's MIM or die cast, kind of the same process that you'd use to make a Hot Wheel. And sometimes the plates come from the factory or from the manufacturer with a slight bend in them. The problem with that bend with the cast metal or MIM is that during recoil those plates can break. So what you end up with is a collection of these. This used to be together. Now it's not. And the reason this happened, this is one of my personal plates, although I do have kind of a growing collection of these, not only the plates that I've broken 3, 2 on a Gen 4, 1 on a Gen 5, but I've had students have them break in classes. I do teach the occasional red dot class. What I mean by that is it's pretty much all I teach these days, both law enforcement specific and open enrollment self-defense shooting. I see a lot of red dot guns and I see a lot of Glock MOSs. So my sample size is pretty big and I've seen more than a few broken plates. So what causes it? Well, because of the plate's overall thickness and the relatively shallow depth of the screw hole, we don't have a whole lot of screw going down into the slide of the gun. If there's any bend in the plate whatsoever, every time the gun fires, the plate can flex and whiplash during that reciprocation of the slide and pull up on those screw heads. After a while, one of two things is going to happen. You're either going to break off one or both of the screw heads, or you're going to snap the plate and you're going to have an optic come back and hit you in the face, or maybe hit a buddy, or maybe just get lost in the weeds, whatever. Worst case scenario, you have a gun that's backed iron sights, which is, unfortunate, but it's a problem that can be fixed. Teaching a lot of red dot classes, one of my recommended fixes for the MOS platform has been the C&H Precision's aluminum plates. I was very excited when I was contacted by Buck over at C&H Precision, and he said he had a next generation plate coming out, so he sent out a couple to me. I received the version 4 Defender, which is the polymer version of their version 4 Mil LE plate, which is made out of aluminum. The version 4 Defender is made out of polymer, and it has almost like a sacrificial shroud. I received the plate that's specific to the Type 1 Holosun 508T. Some of the unique aspects of this plate is the fact that because it's polymer, it wouldn't be wise to necessarily machine the screw mounting interface into the plate. So what C&H did is they introduced 416 stainless steel T-posts that are replaceable. So if you strip one out or if you break a screw off in one, you can swap out the T-post and be good to go once again. And that's, I think, a significant advantage to the overall system, just looking at that one cool little feature. They also include Torx as opposed to Allen or Hexagon hex key. which, as you may have found out if you've been messing around with optics on handguns for a little while now, it's very easy to strip out those small Allen key or hexagon or whatever terminology you want to use, whereas Torx, a lot more surface contact in that design, that star drive, if you will. So it's much harder to strip those out if you're not torquing to spec. My advice to anyone, especially when they're dealing with optics on handguns, is buy, even if it's an inexpensive one, buy a torque wrench so you're torquing to the proper poundage, so you don't necessarily strip those things out, and also invest in a high quality purpose thread locker. VC3 has become my favorite over the past couple of years. I used to use red Loctite, which works, but it does tend to strip out the screws a little bit more if you don't apply the proper amount of heat to break it up before you remove it. With like Vibratite, the VC3, and if you torque properly, you don't necessarily have to apply a lot of heat, if any heat at all, to remove those, especially if you're using a Torx head versus an Allen head. But this video isn't specifically about that. So let's get into the performance overall of the V4. Mounting the plate was very straightforward. It was very similar to just using a traditional Glock MOS plate. It is a little bit shorter, or thinner if you will, than an MOS plate, so I'm going to get a few more threads, 1 or 2 more threads, maybe more, inside the frame, or I should say the slide, than I will with a traditional Glock MOS plate. That's something that definitely appeals to me, because as I said at the beginning of the video, it's one of the failing points of the traditional OEM plates is you don't get a lot of screw down in there. So you don't have a lot of grab on your slide, and you're using an optic and it's reciprocating along with the slide, or maybe you're working it off of barriers or something like that during one-handed drills, or what have you. My personal philosophy, which you've probably heard before, is do not manipulate the gun off of the optic unless you absolutely have to. Very first thing I did once I got it mounted was the burn down. Not familiar? 500 rounds through the firearm as quickly as possible to see if that accelerated rate of fire would cause any issues with the accessory, whatever it happens to be, in this case the V4 Defender polymer plate. 500 rounds is not the same as 500 rounds as quickly as possible. Because the plate's polymer, I had another concern, that is any kind of heat buildup going to cause any issues with it whatsoever. So one thing I was definitely going to do after the burn down was check the zero on the gun. Now, to really accelerate things, no pun intended, I put my registered auto sear on this Gen 5 17 MOS and shot all of that 500 rounds full auto. So here's your burn down. Handguns don't build up heat comparatively as fast as a rifle does, but 500 rounds all full auto, very first thing I had to do after that was immediately disassemble the gun, because the heat started to deform my my frame, which is not something you want. Got it taken apart. Once it cooled down, I put it back together and checked my group. I'd already zeroed the gun previous to the burn down. Very first rounds I fired through it were a 0, and it maintained 0 after that 500 round, and there was no deformation that occurred to the plate whatsoever. And then I just started using the 17 MOS as I would for any kind of optic-specific evaluation. 508 version 1, which I've previously done a video on, already talked about that. The video is not specifically about that. One thing I found with the 508 version 1 is that it was already a robust optic, even with that traditional oval shape, which is one of the concerns I have. Any kind of optic that has that traditional shape like that generally doesn't have the same durability as some of the other optics that's out there. With the addition of the shroud on this particular model, they make one for the Trijicon RMR as well, but this one specifically for the Holosun, I have that polymer shroud that's roughly in the same shape. That provides a little extra protection in the event that the optic comes in contact, mostly for one-handed manipulations or inadvertent contact with objects, or maybe pressure from the side. If you drop a gun, you're probably not going to drop it the same way I do during my drop test, hopefully not. And of course, the whole purpose of the drop test isn't to simulate people dropping their guns, because hopefully that doesn't happen. It's to simulate the most amount of reasonable force I can apply to the optic to see if it causes issues during an optic review. In this particular situation, I'm not reviewing the optic, I'm just looking at the plate. So for my drop testing, I was just looking to see if the drops would cause the optic, or the plate to shift and cause me to lose my 0. Just like with virtually any other firearms accessory that I review, or firearm that I review, or optic that I review, I'm going to do a 2,000 round review process. Specifically for accessories, mounting plates, and optics themselves, I do a drop test every 500 rounds. You're probably very familiar with that at this point. If you're not, you will be. Whole purpose of the drop test is to see if, at least in specific to this review, is to see if the plate would break, shift, or cause me to lose my zero in any way on my optic. So I'm in 2,000 rounds, that's going to be 4 shoulder height drop tests on concrete or any hard surface that I happen to have, depending on which range I happen to be using. It's not scientific, of course, because life is chaos, but I'm the same height, it's always shoulder height. So very first thing I want to show you guys is the 5-round group I fired for zero confirmation before I began the drop test process. Then throughout the review process, I did 4 drops, 1 drop every 500 rounds. And on the 3rd drop, I actually broke the shroud of the optic. I would consider, I'm not saying this is their terminology, but this is how I would refer to it. I would consider that shroud to be almost sacrificial for a purpose just like this. Because it is round in shape, it would be very hard, especially on as many drops as I'm going to do, relatively speaking, for that thing not to break. But it did its job, I think. It protected the optic from more force that it would have taken otherwise. Even though I know this optic to be durable during drop testing, having the shroud there is an additional layer of security I really like. Not only for dropping, but also for, like I said, impact and impact resistance. Now, even though it did break, checked the zero again, then did my final drop test, so 4 drop tests over 2,000 rounds. Here's a 5-round group I fired after the 4th drop. I consider that proof positive that the optic maintained zero through the 500 round burn down, as well as 4 shoulder height drop tests and a lot of single-handed manipulations off of hard surfaces during the 2,000 rounds. Overall impressions of the plate is I think it's an improvement over their previous aluminum offerings. They would say that the version 4 Defender polymer is more of an everyday carry plate. I would agree with that, especially for those who are going to carry concealed. You don't have those duty optic concerns. If you're going to carry a hollow sun or a Trijicon, then this is a great plate option for you if you have an MOS. For those in law enforcement, if you're stuck with the MOS, and a lot of you are, this is going to be a significant improvement over the Glock plate. The Glock plate is trash. And I hate to say that because I like Glock, I really do. But I feel like Glock's motto shouldn't be perfection, it should be, F you, you'll buy it anyway. They, I would say, have to be aware of the problems with the MOS plate, and they've done nothing that I can tell from Generation 4 to Generation 5 to make any changes whatsoever to the plate system. We still get thick, MIM, die-cast, Hot Wheel-esque plates that are prone to coming bent or prone to breakage over use. If you're going to be more than a pedestrian shooter with an MOS using the OEM plate for the MOS, eventually you're going to break one, and your round count probably won't be very high when you do. So we have to go to the aftermarket in order to find a solution for the MOS platform. Using a plate like the C&H Precision, the V4, or their V3, which is the same plate without the shroud, or the V4 that they offer in aluminum, you're going to be much better served than you would be with the OEM plate offering. Final verdict on the V4 plate, polymer plate from C&H Precision. I wish the shroud wouldn't have broken. I wish it was robust enough, but I also have to account for gravity and the general shape and how that shape distributes impact. When things drop, that energy is going to go down the sides, which is actually exactly where my breakage concerned, but it did its job. The plate still maintains zero after 2,000 rounds. Even after it broke, I left it on the gun, continued shooting it. I don't think that's a big deal, especially considering they offer basically the same plate without the shroud. So basically all I did was turn this plate into that plate. Not intentionally, of course, but it is nice to know that you can get a version with a shroud for practically the same price, and you don't necessarily have to worry about, if that does break, that it's going to cause the plate to lose its ability to maintain the optic in its position to maintain zero. I'm going to keep using this. At some point, I want to check out their metal one. I may throw the V3 on there, which is basically the same plate, like I said, without the shroud. But I think this is an excellent addition to the options for the Glock MOS platform, so you don't have to use that really anemic, really poorly thought out, very badly designed, really rushed MIM plate that comes with the Glock MOS. If you're going to be anything more than a pedestrian shooter, I highly recommend getting an aftermarket plate, and C&H Precision makes an excellent plate. I'm Aaron Count with Sage Dynamics. Train accordingly. Hey everybody, Aaron Cowan with Sage Dynamics, and this is the C&H Precision V4 Defender. Why does this thing have such a long name?